My name is M. Narasimha Rao, lecturer in physics. Two identical charged particles are fastened to the two ends of a spring constant 100 Newton per meter and natural length 10 centimeter. The system rests on the smooth horizontal table. If the charge on each particle is 2 into 10 power minus 8 coulomb, find the extension in the length of the spring. Assume that the extension is small as compared to the natural length. Justify this assumption after you solve the problem. According to the given information, there is a spring. Its natural length is 10 centimeter. There are two particles which are identically charged. Its meaning is charge on the first particle and charge on the second particle both are equal. Q1 is equal to Q2. Identically charged particles means both are positively charged particle I am taking. This particle is positive, this particle is positive. Now please listen. This is positive, this is positive. In between these two charged particles, both are of like charges, both are positive charges. There exists a force of repulsion, there exists a electrostatic force of repulsion. Due to electrostatic force of repulsion, there is a elongation in the spring. Length of the spring is increased. Increase in the length of the spring we are calling as elongation. Elongation I am writing as x. X represents increase in the length of the spring. Due to repulsion, length of the spring is increased. Now that is x. Now due to repulsion, length is increased. Exactly. At that time, inside the spring, some forces are developed. Those forces are trying to bring the spring to the original position. Those forces we are calling as spring forces. When these are now, there is a elongation in the spring. At that time, inside the spring, some forces are developed. Those are spring forces. Spring forces are trying to bring this body or bring this spring to the original position. Now inside the spring forces are developed. Those spring forces are trying to bring this spring to the original position. Spring force is acting like this. Electric force of repulsion is acting like this. Spring force is acting like this. They told the system is in rest. Its meaning is electrical force is balanced by the spring force. Here, electrostatic force between the two charged particles is balanced by the spring force. Electrostatic force between the charges. Electrostatic force between the two charges. Now I am taking as Q1, it is Q2. That is equals to K into, if this constant belongs to electricity, K into Q1, Q2 by R square. Distance is L square. That is equal to spring force. Spring force formula Kx. Spring force formula Kx. This belongs to, this constant belongs to spring. This constant belongs to electricity, coulomb. For that reason I have written. Here, minus I have written. Now here, now please, elongation is a left side. Spring force is the right side. For that reason I have written minus symbol. Both are opposite in direction. Now, I want to find this x. Coulomb constant K. K is the constant in electricity in Coulomb's law. 9 into 10 power 9. Q1, charge of the first one. 2 into 10 power minus 8. 2 into 10 power minus 8. Charge 2, second particle charge, same identical charges, 2 into 10 power minus 8. 2 into 10 power minus 8. L, distance between the charged particles 10 centimeter. I am converting into meter. Meter, 10 power minus 1. L means 10 power minus 1 meter. Square, I am writing square. Spring constant, they have given as 100. They have given as 100. 100 I am writing as 10 square. X means elongation. Now please listen. 2 into 2, 4. 4 into 9, 36 into 10 power. Minus 8, minus 8, minus 16. 10 power 9, 10 power minus 16. 9 minus 16, 10 power minus 7. 10 power minus 7. Here, please listen. Minus 8, minus 8, minus 16. Minus 16 plus 9, minus 7, that is equal to 10 power minus 2. 10 power minus 2 comes to this side. 10 power minus 2 is 10 power plus 2 into x. 10 power plus 2, 10 power minus 2 cancelled. X is equals to 36 into 10 power minus 7 meter. Otherwise, x is equal to 3.6 into 10 power minus 6 meter. X means elongation in the spring, increase in length. Here we got x is equals to 3.6 into 10 power minus 6 meter. X is equal to 3.6 into 10 power minus 6 meter, micrometer. 1 micrometer means 10 power minus 6 meter. Elongation is equal to 3.6 micrometer. But in the textbook, now this is the answer given. I am comparing now. Elongation is in micrometer. Original length is in centimeter. Elongation is in micrometer. Micrometer is very, very small when compared to the centimeter.